How's it going, class? So this is going to be a bonus lecture. This is probably gonna be I think this is going to be the only one that I post for this exam section, since we have 6 chapters, and then a lot of this is kind of review material from the first exam group. There's really no need to go into a lot of it more in depth. However, make sure that you are understanding what we went over in the first section, and that you're still remembering it. Not The exam two is not going to be cumulative by any means. I'm not going to be, actually, I'll rephrase that. It is going to be kind of cumulative. So it's not going to be cumulative in a sense where half of it is going to be from exam two and half of it's going to be from exam one. But the exam two material is basically built all on the stuff that you learned from exam one. So I'm not going to be asking you specific questions about some of the material that we learned earlier unless we went over it again. But make sure that you understand all of that material very, very well so that you can use it as a fundamental starting point for the questions and the material that we're going to go over here. And so really the only thing I'm going to go over in a little bit more depth here is the bioenergetic training and the training of the muscular fitness, so strength, hypertrophy, endurance. We're going to get into what each of these things are. And like I said, this will be the only bonus lecture. And this is actually, since I do all the main lectures first and then I do the bonus lectures afterwards, this is going to be the last lecture that I record for this course. And again, don't get confused. This isn't the last lecture chronologically. It's just the order that I recorded them. This ends up being the last one, but it's a little bittersweet. I've spent a lot of time in preparing these lectures, and I hope this last one is good for you. So I'll try to provide the information to you in the best way possible. And let's jump into it here. All right, so training effects on the bioenergetic systems. All right, training effects on the bioenergetic system. So we're going to start enhancing the phosphagen system. So some of this is going to be a little bit of review for what we talked about before. I just want to make sure I'm touching on all these things again and kind of hammering home these concepts. So if you look at this and you're like, oh, I already remember this stuff, you can go ahead and kind of ignore this part. Otherwise, always a good refresher and good for you to understand this stuff. So our phosphagen system here. Training that elicits adaptations are going to be all training. So anything that's like a sprint, a 1RM, power training, right? Remember that you are providing some sort of stimulus that is stressing this energy system, that is causing this energy system to be highly active. And so in order for that same stressor in the future not be as detrimental to you, your body is going to adapt. And so you can upregulate cytosolic creatine kinase here. You can supplement with creatine to increase your creatine stores. You can upregulate mitochondrial creatine kinase, upregulate some of these other enzymes in this internal cascade, as well as upregulate ATPase, or excuse me, downregulate the inefficiency of ATPase and upregulate its efficiency. But essentially, you can increase enzymatic efficiency and availability with training. So with this, not only you're increasing the amount of enzymes that are available, you're increasing their efficiency. So essentially, you're making this system better at its job. And so we'd also talked about before with creatine supplementation, you can enhance the ability to store phosphocreatine and also rephosphorylate creatine into phosphocreatine, which means that there's more ATP being made in your rest intervals or in between sets. And so that allows you to essentially work harder on your next set, which means that you are going to get more muscular damage and therefore more adaptation. And so it takes about 3 to 5 minutes for full recovery. So this time limit should be pretty ingrained in your head. As we go into the training for muscular strength and power later, you'll understand when that time, why those time limits for rest times, excuse me, why those rest times occur in between strength training or power training sets. As well as, right, it can be enhanced by creatine supplementation. So we said this, enhancing creatine by taking enhancing creatine stores and phosphocreatine stores by supplementing with creatine is beneficial for strength and power training. So enhancing the glycolytic system, again, we see here glycolysis is producing our pyruvates. We see the more complex reaction up here. So trainings that elicit adaptations are longer duration sprints, repeated sprints, 8 to 12 rep ranges. So things that are taking anywhere from 10 seconds to about 120 seconds are going to stress the glycolytic system. You're essentially stressing the body's ability to metabolize glucose to quickly and inefficiently in this way produce ATP. So with this, you can increase enzymatic efficiency and availability. You're increasing acidosis removal capabilities, so we're increasing the capabilities of the bicarbonate buffering system. We're increasing the capabilities of your muscles to handle the acidosis in the first place. With this training, you're going to have higher intramuscular glycogen storage. So again, if we have higher stores of intramuscular glycogen, that means glycolysis can occur more quickly. Just like if we have wood next to the fire versus if we have wood a mile away, obviously it's much easier to burn that wood that's right next to the fire. Same thing here. If we have glycogen in the muscle, it's much easier to utilize that glycogen for fuel than it is to mobilize glycogen from the liver, have it transfer through the blood via glucose, come into the cell via the GLUT2 and GLUT4 receptor, and then be converted into GLUT6 so that it can be metabolized through glycolysis. Obviously, that's a much longer process. So if we have stored glycogen, it's much more easily converted into ATP and then pyruvate for the electron transport chain in the Krebs cycle. Better glucose transportation into the cell. So that's what I said. Obviously, we have these higher stores. So these stores, these glycogen stores are higher. Like I said, we want the wood next to the fire, but also that entire cascade that I just explained with the glucose being mobilized from the liver, that is also increased. So not only do we have a larger pool of fuel, do we have a larger pile of fuel or pile of glycogen, but also whatever's replenishing that, glucose being mobilized, or whatever's filling back up our wood pile next to the fire is also more efficient. And therefore, we can just have more readily available glycogen in the area already, and it's being replenished more efficiently as well, so that you can do longer or more intense exercise. It takes 1 to 3 minutes to fully dissipate negative byproducts and function at full capacity. So again, this rest time should look relatively familiar as we go through this lecture, excuse me. And then enhancing the oxidative system. So training that elicits adaptation, so long duration aerobic exercise. If you want to enhance the oxidative system, you need to do exercise that stresses it. And the exercise that stresses it is long duration aerobic endurance exercise, right? So increase enzymatic efficiency, again, that should be a very familiar thing. All three of these systems rely on enzymes, and if you're increasing their availability and efficiency, you're going to be increasing the efficiency of the system as a whole. So you can increase pyruvate shuttling into the mitochondria. Remember, when the glycolysis is functioning too quickly and this pyruvate is building up and then essentially not being able to get into the mitochondria, if it's going through glycolysis too quickly and the Krebs cycle is not able to handle that pyruvate, we get buildup and we get acidosis, as well as the Krebs cycle system, or excuse me, as well as the pyruvate itself being shuttled into the mitochondria is not always the most efficient process. So if pyruvate is being produced too quickly, that it's not allowed to get into the mitochondria, as well as if mitochondria getting into the mitochondria, or excuse me, if pyruvate getting into the mitochondria at all is inefficient, then we're going to have a slowdown of the oxidative system. So not only in this way are you essentially increasing the capacity of the Krebs cycle, this will make more sense, even though I just stuttered all the way through that. Not only with this are you increasing the capacity of the Krebs cycle, but you're also just increasing the capacity to get pyruvate into the mitochondria in the first place. So I apologize that 30 seconds there. I was basically having one of my patent strokes that I seem to have pretty much every lecture. But increased pyruvate shuttling into the mitochondria allows us to get the pyruvate out of the cytosol here, as well as it allows it to be more readily available for the Krebs cycle. And since we had an increase in our enzymatic efficiency and availability, oh, my screen just freaked out. What's going on? I don't want to restart this lecture. There we go. Hopefully you guys can see it and it works well. I'll insert the lecture. So we're going to keep going here, keep chugging. If you're increasing the amount of pyruvate that's getting into the Krebs cycle and then increasing the amount of substrates or amount of enzymes that are breaking down that pyruvate, you're going to enhance the oxidative system. Increased mitochondrial density and efficiency. If we have more of these mitochondria, so now if we have more of these mitochondria, that means that they can take in more pyruvate, as well as if they're larger, again, they can take in more pyruvate. So now we're increasing the enzymatic efficiency within the mitochondria. We're increasing the amount of mitochondria. We're increasing the size of the mitochondria, which means more Krebs cycle, more electron transport chains. And we're increasing the capability of shuttling pyruvate into the mitochondria, all of which are going to lead to enhanced endurance performance, as well as increased oxygen delivery to the working cell. So specifically to the mitochondria. So increasing oxygen delivery, upregulating red blood cell metapoiesis, upregulating the amount of heme groups, upregulating heme group function is all going to lead to increased oxidative output and therefore increased endurance performance. And this requires a little rest times between. Rest time usually required for the inner portion of exercise. So usually if you're doing a strictly aerobic exercise, or you think you're doing a strictly aerobic exercise, there is a little bit of an anaerobic component. There is a little bit of glycolysis occurring, or there is a little bit of overdone glycolysis occurring, which means there is a little bit of acidosis occurring. And so usually after you get done with aerobic exercise, predominantly what you need to rest for is just to help clear some of the anaerobic metabolites that have occurred. For the most part, if you are readily replenishing the oxidative system with substrates like glucose to make pyruvate, you will not have to worry about a rest time. Rest time is predominantly for the anaerobic mechanism, but it's kind of hard to distinguish those two. So oxidative exercises sometimes need a little bit of a rest time. Increased oxygen delivery to the working muscle cell, specifically mitochondria. Right? So diffusion of gas in the lungs is not the rate limiting. It's not the rate limiting factor. I hear a lot of people, like I said before, will say, "Oh yeah, my lungs gave out. My lungs gave out, and that's why I stopped." It's not really true. We talked about this, partial pressure can be thought of as an absolute amount of particles, and so with adaptations training or with the aerobic adaptations, like I said, we talked about in our other lecture, what you'll see is that this process right here, the extraction of oxygen from the blood, the extraction of oxygen, terrible arrow, extraction from oxygen from the blood into the cell and then into the mitochondria becomes more efficient. So we can get more oxygen across into the cell, as well as now that there's more mitochondria in the cell, there's more cells, or more mitochondria to utilize that oxygen. So again, we have more of these mitochondria. They're larger, they're more efficient, so they're better able to utilize oxygen, but are also more capable to give them oxygen, which again is going to lead to increases in our aerobic performance. The training affects anaerobic principles. Excuse me, I'm drinking my Monster here. Yes, I still drink White Monster because I didn't ruin for myself as a chaser in college, so I actually do enjoy it. Which I'm sure I think a lot of my friends see me drink White Monster and they think I'm crazy because they all ruin it for themselves as a chaser in college, and I didn't. So nice because delicious, right? But jumping in here, enhancing VO2 max. This should look very, very similar. Any training that stresses the mechanisms of ATP production by the mitochondria. Lost my cursor here. Move my face here. Stress the mechanisms of ATP production by the mitochondria. Increase enzymatic efficiency and availability. Increase pyruvate shuttling into the mitochondria. These are all things that we saw for enhancing the oxidative system. This may be very, very redundant, but some people don't make that connection. That when you're increasing the capabilities of the oxidative system, you're increasing VO2 max, because VO2 max is a proxy measure that just measures the maximal ability of your body to consume oxygen. If we know how much oxygen you're consuming, that means we know how much ATP you're producing via the oxidative system. Enhancing lactate threshold and ventatory threshold. So training that causes acute or prolonged acidosis. So if you want to train or you want to modify and augment your body's ability to handle acidosis, you need to put it in a stressor that causes lots of acidosis. So this is what HIIT training is good for. If you're doing high intensity interval training and repeated sprints, you're basically spending the entirety of each of those sprints above your lactate threshold. So you get this massive dose of acidosis, and then your body can clear it. You get another dose of acidosis, and your body can clear it. Another dose of acidosis, and your body can clear it. This is different than if you just were to run a mile. You're really not getting above your lactate threshold until probably the near end of the mile. If you're doing HIIT training or repeated sprints, you get like a 30-second dose of acidosis, then you get rest. 30-second dose or whatever your interval might be. And this helps train the body's capability to buffer and to mitigate that acidosis. As well as it's going to increase your red blood cell count. So again, this is part of ventatory threshold and part of our aerobic system, increasing red blood cell count, allows for oxygen delivery, as well as it helps to remove carbon dioxide from the tissue, which remember is one of the ways that we buffer acidosis. And this is going to allow for a higher pace of speed. And so we talked about before, lactate threshold. If you have somebody who has, let's say, a race pace of 7 miles per hour, which is right below their lactate threshold, and then you put them through a training regimen, you might be able to get their lactate threshold to a point where now they can run at a race pace of 7.5 miles an hour, which is realistically quite a bit faster. And if you're running a marathon, it's going to shave quite a large portion of time off of your marathon. So essentially, this is the ceiling or the top speed at which you can run before you fatigue very rapidly. So if you can enhance this in endurance athletes, that means they can run at a constant or a faster constant pace, which means their race times are going to be quicker or lower. Training effects in the musculoskeletal system. So muscular fitness properties. So we should know these: muscular strength, endurance, and then muscular power and explosive strength. So the reason that I have explosive strength here instead of just muscular power is in the literature and in description of what really is occurring is it's hard to say muscular power because we know the formula for muscular power. We know it's work times or work over time. And in work, there's displacement. Well, if you do a vertical jump, if you jump and you land exactly where you were before, you have no displacements. Technically, you had no power. But so that's why explosive strength has been used to describe this, because technically calling it power is incorrect if you were staying in the same exact spot. It's kind of one of those physics things where people like to argue about it. But just explosive strength helps to mitigate any confusion. But in reality, explosive strength, power, pretty interchangeable and the same thing. Again, we're reviewing motor unit recruitment here as well. Motor units and alpha motor neuron and all the muscle fibers that it innervates or activates. Same thing, innervates, activates means the same thing. Smallest motor units recruited first due to their lower activation thresholds. We said before that smallest motor units are always recruited first. And as you can imagine, if you just thought about this in general, if you thought about these as like trees or anything, you thought about these two neurons as trees, which one of these is going to be the easiest to influence, to change? Well, the smaller one, right? Same with motor neurons. If we have two motor neurons here, which do you think is going to be the easiest one to stimulate or to change? Well, again, the smaller one. That's what the size principle is. Larger, more intense stimuluses are required to stimulate and to change these large diameter motor neurons. So if we want to enhance muscular fitness attributes, you must first recruit the fibers. You have to provide a stimulus that recruits the fibers. So if you want to train a fiber at all, you have to make sure, first of all, that you're using it, right? And then you must fatigue the fibers. So you must put the fiber through enough stress that it gets damaged so that it will go through an adaptation and therefore see gains or changes. So here's just a basic recommendation of your rep ranges for certain exercises. So you see here on the left, we see our power and strength. Realistically, strength should probably be more like 4 and below, and power should probably be more like 3 to 6 is really the best way, or 3 to 5 is the best way for it. For the hypertrophy right here is strong, and muscular endurance here is strong. These are your rep ranges. If you look here, we remember a lot of people that train when they're younger train this 8 to 12 rep range. And that is why you see a lot of hypertrophy style lifting, because it's been in use in training for a very, very long time. But now, as we've become smarter and we have more information, more literature, we have more anecdotal evidence, we find that for power athletes, you should probably be training in this power zone here, right? Because that's what you're the most worried about. This is just a basic graph what we had before showing you the relative contraction times. This is more for you to look at and understand and say, okay, so my type 2X fibers, how are they compared to my type 1 fibers? And when I'm doing certain training, how are they affecting these fibers and what training is using these fibers, essentially? You don't need to know. I'm not going to ask you what is the level of power produced by a type 2X fiber. But I might ask you a general question saying are type 2X fibers more or less capable of developing power than a type 1 fiber, or something like that. So strength training, okay, so you're going to want to be at greater than 85% of your 1RM. So if you want to train muscular strength, which is the ability of the muscle to maximally contract and produce force, you need to put it into a stressor where it's pretty much maximally contracting and producing force. So this is maximal muscle fiber recruitment. So you're getting the most muscle fibers recruited. As we can see here, when he redoes this lift here, I'll wait for him to start. It takes him time. He can't do this very quickly for quite a few reasons, but it takes him time to develop all that force. So it's taking him time to recruit those large motor neurons, as well as the only way you can lift that force is if you recruit those large motor neurons. And so with this, you are recruiting the most fibers, but because it is such a short duration, that does not necessarily mean you are fatiguing the most fibers. And we'll talk about that in a second here. But just because it's recruited does not mean it's being fatigued, and does not mean that the stressor is causing it some sort of change or stimulus to go through adaptation. And then for this, again, 3 to 5 minute rests. Should look pretty familiar. 3 to 5 minute rest is our rest time for our phosphagen system, right? So muscular strength requires greater than 85%. Most fibers are recruited. So look over here in this diagram, it's a little small. It's poorly drawn because I drew it myself. But essentially, anything that's white is not recruited. Anything that's blue is recruited. And then anything that is red is recruited, fatigued, and trained. Okay, so we see here, we get this massive amount of recruitment. But in reality, because the duration of the exercise is so short, we're not really training these type 2A fibers here. We're not really training these type 1 fibers here, right? We're only training those those high echelon type 2 fibers that are really, really bad at lasting a really long time. Those are really the only fibers that we're stressing, okay? This relies heavily on the phosphagen system, like I said. Now, when we look at power, so you want to be at 70 to 80% and higher. So essentially, the idea of power training is you want to have some sort of relatively heavy load, but you're trying to move that heavy load as fast as you possibly can. So recruitment near maximum amount of fibers. There's some literature that says that power training might recruit a little bit more muscle fibers. That has to do with eccentric training and whatnot. We're not going to get too much into that. But essentially, we'll assume that it recruits near maximum amount of muscle fibers. So this focuses more on the rate of contraction rather than total force production. So this is focusing on rate of force development. It's not really training the muscle fiber to be able to develop force in general. It's training that muscle fiber to generate that force quickly. So you're having faster ATPase activity. You're having faster calcium release from the sarcoplasmic reticulum. All of those mechanisms that allow for muscle contraction to occur are occurring more quickly and more efficiently. And that's essentially what power training is meant to do. And again, we see this pretty noticeable rest time that we've talked about before. So that's why you see power trainers will go in and they'll lift a set 3 by 5, and then they'll take like a 5-minute break. That's actually what they're trying to do if they're trying to generate the most power for their movement. So muscular power here, again, we can see this on the side, relies heavily on the phosphagen and some glycolytic system, and increases our rate of force development, quicker cross-bridge cycling. And again, here we see, though, is that we see a lot of recruitment, but not quite as high as muscular strength. But the window is still relatively the same. We still have a very small window of fatigue. And these, again, are the only fibers that are really being trained properly. Obviously, these down here are all being trained a little bit. You're going to see maybe a little bit of adaptation. Like this one, you're going to see some adaptation. This one's going to be even lesser. And then as you go down the continuum, you get to a point where there's probably absolutely zero adaptation if you're well trained. But this is the predominant window of training that you're going to see. Now looking at muscular hypertrophy. And so we talked about before the difference between myofibrillar and sarcoplasmic hypertrophy. Sarcoplasmic hypertrophy is going to be good for longer duration events because you are increasing glycogen stores in the muscle as well as buffering capabilities in the muscle. So this is going to be a little bit more common in exercises that are a little bit longer duration. So like 400-meter sprints, things like that. Or if you're doing longer duration reps in your exercise. And then myofibrillar hypertrophy is going to be good for increasing the force components of the muscle. So if you're increasing the amount of myofibrils, that means more force, or that means more force being produced by cross-bridge cycling, which means that you're going to be stronger in that movement. And so muscle hypertrophy is about 60 to 80% of your 1RM. This is what's going to cause the greatest amount of muscle fiber fatigue. So muscle hypertrophy training is going to cause the greatest amount of fatigue, and that should make sense. Muscle hypertrophy training, as we know it, is muscle growth training. And if you're seeing the greatest amount of muscle growth in this muscular hypertrophy window, that must be because you are fatiguing the highest amount of fibers. And really what hypertrophy training does is it's kind of like this. Since you're at 60 to 85% of your 1RM, in your first set, you get recruitment out to about here, and then you have fatigue window kind of like this, okay? So you have a fatigue window kind of in this small area. But going into your second set, more than likely, because the rest time is about 60 to 90 seconds, these muscle fibers are still relatively fatigued. And so you can kind of recruit up another echelon. So recruit up another echelon, as well as now that you've only allowed a somewhat short rest time, let's say 90 seconds, now you are starting to fatigue this fiber because it's a longer duration exercise. You gave it some rest time, but you didn't give it adequate rest time for this fiber to become fully replenished. And so now it's fatigue. And then we go on to the third set, and we see here that we recruit up even more. So now we have these fibers that are all tired, are all fatigued. So we have to recruit up one more fiber again. And then also because we have that shorter rest time, we're becoming more aerobic in nature. So you're getting this widening window of fatigue. And obviously, this isn't like a set number. It's not like one more fiber every single time. It's giving you the general idea that this window of fatigue begins to expand with every set or with increasing volume, which is what causes the greatest amount of muscle fiber fatigue, which is what leads to the greatest amount of muscle size increases or muscle size gains. Muscular endurance, so anything less than 65% of your 1RM. So minimum muscle recruitment, again, we should know we have a short rest periods. And with really, really aerobic endurance events, you get very little muscular recruitment. This is why aerobic athletes are very, very small, because type 1 fibers are very, very small in nature. And you're not really training their capability to develop force. You're training their capability to produce ATP via the oxidative system. And so you don't get a lot of actual fatigue of muscle fibers because you are working on the fibers that are the most fatigue resistant. And so really what you're training is just their ability to produce ATP via the oxidative system. You're not really stressing the muscle in terms of its contractile capabilities because it's not really going through really strenuous contraction because it's an endurance, long duration exercise. And so that pretty much sums up what I want to go over in this lecture. So some of that is review, but I just wanted to kind of like dive into each of these, dive into these things a little bit more and help you guys understand what each of these things means, how you can relate to proper training, as well as something that I get asked a lot is about how the training styles are different, how we properly manage rest times, how we do these to ourselves. And so those of you who are practitioners or PTs or OTs, or if you just want to use this information for yourself, I think it's a good way for you to a little bit more dive into applying this knowledge. So I've given you guys a lot of physiology throughout the semester, and now this last group of 6 chapters is a little bit more about application. So I wanted to create a more direct link in a smaller, shorter lecture, so you can kind of go back and go, okay, so if I'm going to train hypertrophy, what should I be doing? If I'm going to train strength, what should I be doing? And then also, while I'm doing these things, what's happening? How am I getting this ATP? Why do I feel tired? Whatever it might be, what do I need to modulate to make myself more trainable, make myself more adaptable so that I can become better at my performance or whatever it might be. But other than that, that pretty much sums up the lecture. I hope you guys are enjoying the course so far, and I hope you guys have a good rest of your day. See ya.